Okay, I have decided to go ahead and pull the amplifier board while I'm still working on the power supply. I already removed this one wire here with a wire wrap tool. I have a wire wrap tool, and you basically just put it on there, turn it, and it pulls the wire wrap off. That's going to be a little bit more complicated for the red and the white because they are actually soldered onto the board. But as you can see, all you do is just take the end of it, put it on the post, and then turn it counterclockwise, and then the wire will unwind and you can just pull it right off. Sometimes you can get it off there without breaking it, and then sometimes you can't. That time I got it off there without breaking it, but this other one, you can see it broke off. So I'll end up just stripping those and putting fresh version of the wire on when I retool it. To put it back on, you do the exact same thing. You just feed the wire through the hole in here, and then you slide this on and you turn it counterclockwise, and it winds it back to the post. So the only other ones I need to do are there's a red one, a black one, and a white one here, and then this white and red, and then the whole board should just come completely out from the other side. So I'm going to get that taken out right now. And just like that, it's out. It was pretty simple. There were just 4 screws, 2 on this side of the bracket, 2 on the other side of the bracket, and it literally fell right out. So just going to start triaging this board. I'm pretty sure this transistor is blown, which means effectively that I'm going to replace all 4 of them anyway. All of these electrolytics will go. Like I say, this is an original. No one's ever been in here before, so it's important to me to replace all the electrolytics on this, almost 50-year-old board. So I'll test every other thing in here, test to make sure that all the resistors are in tolerance, and maybe I'll consider replacing. I think those are tantalums. I don't have my glasses on, but it looks like those are tantalums. So I'll check into that. But this is a small board, very compact. So we'll just get started working on that. First thing I think I want to do is I want to try and get it off the heatsink. And so I think in order to do that, I'm just going to take these 4 screws. There's 2 on this side and there's 2 on the right side. I can leave the 2 ears on heatsink. It's not important. And then I need to pull out these 2 screws on this side, which will release this bar, I believe, that protects those transistors. So let's get that going right now. And just like that, easy peasy lemon squeezy. Okay. Yeah, I don't see any obvious damage, but I'm pretty sure this one's bad. But I've been wrong before. Will be again. This might be a candidate for the ultrasonic bath. So, yeah. Everything else looks okay though. So I'm going to start pulling some of that out of there. I'm going to pull these transistors out, test them. Sanyo. They look like the same. Yeah, they're Sanyos. B507D for the PNPs and D313Ds for the NPNs. Interesting. So, okay, let's get that cleaned up. Okay, not a lot of wash today, but we're going to get it done. 71 degrees Celsius. That is warm. Warm on the fingers. Okay. Let's get this in here. And just because, we'll go ahead and throw that in there. All right. What? 72, 71. All right, we're done. Okay, let's get this stuff out of here. That's hot. I'm not going to take the basket out. There's only two things in here, so I'm just going to reach in with a pair of needle nose and pull those out. And we'll just put those on the towel over here. And that glue. It just got all clean and chunky. We'll just scrape that off of there with a plastic scraper. While we wait on its power supply part to come in, let's turn our attention back to the amplifier board and just get the caps reinserted. And before we do that, I think I'm going to go ahead and put the emitter resistors in. That'll be easier to do without the caps in the way. All right, the specifications calls for a 0.47 ohm at 2 watts. I'm going to replace them with these KOA Spear 3 watts. One other thing about installing these is that if you look at this board, you can see that all the lettering, or most of the lettering, is facing this way. So I don't want to install the resistor with it facing backwards. I want to install it so that you can read it the same way that you read the rest of the board. And I also want to make sure that the lettering is up, not harder to see. So I want to try to get it as close to, readable as possible. That little white thing behind it says 0 ohm resistor, so it doesn't matter what it is. Doesn't matter that it's touching the emitter resistor. Now I just got these legs in there and flush with the board just because I wanted to get the lead spacing right. I'm probably going to pull those up off the board a little bit so that the heat coming off the emitter resistors doesn't affect the PCB or any of the other components that will be around it as much as if it were on the board. So what I decided on the height is this. You can see it on the right. I haven't done the left side yet. So the reason I decided to make this one a little bit taller is that I will probably bend this one a little bit forward. to get it away from this other emitter resistor and away from this capacitor here, just to give it a little bit more room to breathe. And I might bend this one a little forward as well to keep it away from this transistor as far as I can. So I don't want to bend it too far forward because we have a capacitor here and we don't want that capacitor getting hot. But anything is better than directly on the board. So I'll repeat the process on this side and we'll come back. Looks like I accidentally desoldered that 0 ohm resistor at some point, thinking it was probably the emitter resistor leg. That taken care of. I did it on the other side too. All right, on to the capacitors. I think that looks good. For C21 and C22, we have 2200 microfarads. They're supposed to be 35 volts, but I'm going to use these KA series Nishikon 50 volt versions, which are absolutely beautiful. So I think before I put that in there, I'm going to get C724 and C723 put in, because if I put these in first, clearly we'll not be able to get to that easily. So let's look that up. Okay, for these two spots, I'm going to use these WEMA caps. They are very low noise and they're excellent quality and will last forever. And the pins are the same leads are the same lead spacing as what we need. So let's kind of drop those in. And these are non-polarized, so we don't have to worry about the polarity markings on the board. And I'm dropping that in from bottom to top reading, because if you look over here on the right, you'll see that they do bottom to top or left to right reading. So we want to make sure that we're doing the reading left to right as well. And we'll do the same thing for this one. Perfect spacing. Drop those in. Lead spacing is a little bit off on this one, so they're going to stand a little bit proud, but it is what it is. There's some big holes. See if I can do this without putting it in a board mount or taping them down. I might have to do one side and then adjust. I might have to do both sides and then adjust. Trying not to burn myself to death. Okay, that one's good. All right, I think that looks good. I think that looks nice. It's in there well. Polarity is correct. So let's get the rest of them in there. C709 and C710 right here in the middle are spec'd out to be 100 microfarads at 10 volts, but instead I'm going to use 100 microfarad at 16 volts, you know, because progress. These are the Nishikon UKL series. I think they'll stay. Otherwise, I'll just tack them in and push them through. Well, it's almost right. It's not right. Now it's right. This one's a little wonky. Now that's right. Good. I think those are right. Almost. Still a little off. Okay. There we go. Good. C5, 6, 7, and 8, which are these 4 spots you can see here, are called for 100 microfarads at 35 volts, and it's exactly what we're going to put in them because that's what I have in stock. I have these Panasonic 100 microfarad 35 volts, and they are the EEU FR1V101B. So, they're good caps. Let's get those put in. Well, I finally got tired of dealing with this board sliding all over the place, so I just put it in the clamp. This capacitor is being a challenge, so it was easier to do it in the vise than to keep fighting with the table. So there we are. That looks good. You can see these have the little standoffs built into the legs. And polarity is correct. We'll move on to the next one. I'm about to make a bonehead move. I'm inserting the capacitor backwards. I'm putting the negative lead into the positive hole, and this will cause me
hours of frustration very soon.
Well, come on. Let's clip some leads. So I've been on the fence about replacing these two tantalum caps here in the front, C701, C702. These are 1 microfarad capacitors. Well, at least they're supposed to be. And a couple of reasons. Sometimes I'm not the biggest fan of replacing the tantalums. They're fine. But the bigger point here is that if you look at the lead spacing on these, they are super small. And what I would replace them with would be a WEMA film cap of the same size but larger voltage. But if you look here, look at the lead spacing on this WEMA cap. You can see well, you might not be able to see it, but it is long, it is wider. So this cap would have to sit proud. And you can see that the WEMA cap's legs are just as big as the whole circle where the tantalum cap is sitting. So that's another reason I would not want to replace it. But let's just check the capacity of these two tantalums and see where we're at. So here we are, the first one on the right. And this is at, well, you might not be able to see it. 1 second. The one on the right is coming in at 1.73 microfarads. And the one on the left is coming in at, that helps if you get it on the right leads, 1.58. So those are clearly drifted up. I'll pull them out, test them again just to make sure that they're drifted. And if those are the accurate numbers, then I'll just go ahead and put the film caps in anyway and deal with the ugliness of it sitting off the board. Okay, let's try this one. Well, that's almost exactly what it's supposed to be. It's within 98%. So it could have been me measuring it in circuit that threw it off. That's 0.98 of a microfarad, 989 nanofarads. So that one looks good to me. Let's see if we can get it to measure. Okay, we'll go around again. That one. ESR of 7.4 ohms. That does not look great. So let's test it. Let's test the other one. Yeah, it's about the same. This one's a little low, 1 kilohertz. So let's test a WEMA film cap just to see the difference between those. .53 ohms. So yeah, I think I'm gonna go ahead and replace these tantalums with these WEMAs. It'll be better in the long run. Well, they're a little bit proud, but they don't look too bad there. I think that'll be fine. So we're just gonna get those tacked in and move on. Okay, let's get the last two installed and test this board. The last two caps on this board, 703 and 704, the specs are 47 microfarads at 50 volts, and we are going to up the voltage to 63 volts, and we're going to use these Nishikon 47-63 UKL series, because I have them in stock. So this will go just like that, right there on the board. Nice. And this one will go right over here if I can use my left hand. Nice. This one I might be able to just hold in by my hand. Okay, we'll get this cleaned up, get all the flux off of the board that we just added to it, and then we'll fire this puppy up and see how she performs. Now, I've already tested these transistors and they all looked good, so I'm not going to replace any of those right now. We'll just get it tested and go from there.
Okay, so what we're looking at right here is the service manual for the Marantz 2215B. And this is specifically the schematic, as you can see, for the main amplifier board. It's split right down the middle here. You have the left channel and then you have the right channel. These two are mirror copies of one another. They're exactly the same component. So you really only need to look at one side in order to understand the other side. I wasn't very confident in a lot of the things that were mentioned on this schematic. For example, if you look here, you can see there's 21.9 volts listed here, and there's 22.2 volts. So you can't have two different voltages on the same piece of wire. It just doesn't make sense. So what I ended up doing was building half of this, just as you see, the top half, in a circuit analyzer, and I used circuit everywhere. So let's take a look at that right now. Okay, now we're just looking at a screenshot of the circuit with all of the voltages listed as it's running. Right, so it's built exactly the same way we had before. The same component values, same everything. But the good thing about this is that I can verify with actual inputs. So this has 53 volts input, which I think I actually redid that to change it to 52 because it's somewhere between 51 and 52 volts coming out of the power supply. So this allows me to look at it and go, okay, yeah, I know this is what's actually going on. So now let's switch over and look at the actual analyzer itself running. Here is the simulator. Right, you can see I have this 8 ohm resistor here that is simulating my 8 ohm speaker. I have a 1 kilohertz tone generator on the left. I think I have that set to 250 millivolts, 252. Let's change that to 250. So this is just simulating a tone coming through the circuit that we've already seen, and this allows me to look at it and understand how sound is traveling through this amplifier. Here are the two complementary NPN and PNP transistors. So we can see that we're getting a signal through our speaker because this sine wave at the top is our speaker. So if we select the first transistor and we look at what that's doing, we can see that it is showing the top half of, or right now it's shown on the top because it's only doing half of the wave. Now, if we were to look at what's coming out of the other transistor, we'll do that now. You can see it is taking what's coming out of the bottom part of the half and putting it positive. So this is exactly the way it's supposed to work. One half gets amplified by one transistor and one half gets amplified by the other half of the other transistor. This is the quasi-complementary design. Okay, so let's talk about these 4 output transistors. We're sitting here on the P700 main amp tab of my spreadsheet for this Marantz 2215B. And the 4 output transistors are on lines 27 through 30 here, these lines. And so let me scroll up and make it just easier for you to see. The output transistors are 711, which is here, 712, which is over here, 713, which is here, and 714, which is right here. So you have 2 NPNs and 2 PNPs in a quasi-complementary arrangement. And then you can see the gains that we have for each one of those. 96 is 711, and its complement, 713, is 91. So you have 96 and 91 there. And then for the NPN for 712 is 102, and 714 is 79. Definitely not very good, but not very well matched on this side of the board. This side of the board is pretty closely matched. 96 and 91 is not too bad for as old as these are. For now, I'm going to leave these in. We're going to run some tests and see how it performs. May consider replacing these. I have plenty of them, but I'm going to leave these in for now and see how it goes. Okay, I ran extensive tests on these 4 transistors. On the left here we have the pair 711 and 713, and on the right we have 712 and 714. This is just reiterating what I've already shown you. We have 79, gain of 79 here, 102 here, 96 and 91. I'll briefly show you the rest of the tests. Here are the curves for transistor 711. You feel free to stop the video and look at them more if you like. I find this one to be the most interesting. They all look normal. Instead of simply showing you all the graphs, I think it's more beneficial to show you the differences between the 2 complementary pairs on the right hand side. Now here are the 2 graphs of 712 and 714. So you have the NPN and then you have the PNP here. These are to work together to display or output the positive and negative sides of the signal that's being given to the amplifier board. And these gains should be very similar. You don't want this one being really low and this one being really high. And as you can see, this PNP part is not doing its part, right? It's not performing as well as the NPN equivalent that it's paired up with. So if you look at each one of these graphs, this one's a little harder to see. I wish this software was a little bit better in as far as the graphing goes, but it is what it is. Yeah, here again you can see a little bit of the separation between the 2. But this one is most telling.
And now the fun task of applying thermal grease to these pads. I'm going to apply it kind of in this area. Well, it doesn't really matter. I'm going to have to flip it over anyway, and then I'll end up cleaning the mess up. I don't have any sill pads that are this shape, so I'm just going to reuse these mica insulators that are on here, that were on here. Okay, that's probably good enough. Now I'm going to get messy. All right, now just move that around a little bit. That's good. Now we'll do the other one. I have a better brush for this, but I don't know what I did with it. I'm sure I'll find it as soon as I'm complete here. I think that's probably good enough. Okay. Okay. And I'll put some thermal grease on the back of the transistors that will touch this. Well, this is to prevent the conductivity of the transistors to this heatsink. Because if the back of the transistors actually touch the heatsink, it would destroy them immediately.
At this point, I have had the amplifier board sitting on the desk for about half an hour. It's been warming up, and I've been monitoring the bias on each channel. Right now I'm setting the bias of the left channel to 10 millivolts. Now you'll also notice that you see two resistors, one on each side of the trim pots that I'm turning, the left one and the right one, and the resistors I'm talking about they're standing up. There were lamps there before, and I've ordered new lamps, but one of them was out, so the board wasn't functioning correctly. So I replaced those with 10 ohm resistors, and I'm setting the board up. They'll be fine. The new lamps that will come in will be about 10 ohms, and then I'll reset the bias again. So here I am adjusting the bias of the right channel, and again the target is 10 millivolts. Once I set the bias to 10 millivolts, I let the amplifier sit on the desk for about 3.5 hours and just monitored the voltages across the emitter resistors. And it drifted up and down for a while, but eventually settled down to 10. So once I get the new lamps in that go on each side, I will reset the BIOS and make sure that they are set correctly again. But I wanted to go ahead and run some audio tests on this board to see how those transistors are behaving. So I wanted to ensure that the BIOS is set correctly before I do that. Okay, so it's been a few days since I ordered the lamps from Dave at dgwojo.com. Thanks, Dave. Here's the board just being cleaned up, and that's it. All the flux removed. Here's a photo of the lamps installed, and they both measure out about 6.6 ohms.
Okay, so we finally got the amplifier board back in the receiver. Power supply is complete. Both of those are done. We're going to fire it up on the dim bulb and see if anything is broken. So let's do it. Okay. Right now it looks like it's pulling about 20 watts on the dim bulb. So everything looks good. No smoke. Let's take it off the leash. Okay, now it's running straight off of mains, and at 119 volts even, we're at 21 watts with volume all the way down. No signal into it and no speakers attached to it.
I left the receiver on for about 24 hours, and the bias of both channels is spot on at 10 millivolts. The receiver is drawing exactly 25 watts of power at idle, which matches the specifications perfectly. The component temperatures on the amplifier board are low and are only about 25 degrees above room temperature. Last night, I pushed the receiver very hard with all sorts of music, and it sounds amazing. The FM reception is poor, so after recapping that board, I will need to do an alignment on it. Next up, I will service the rest of the boards in the receiver and then move on to the FM and AM alignments. That pretty much wraps up this part 2 video of the Marantz 2215B restoration. If you enjoyed the content in this video, please consider liking and subscribing, and as always, have a blessed day.